And this question is given that the velocity of small ball of mass m and density d when dropped in a container filled with glycerin becomes constant after some time. If the density of glycerin is d by 2, then the viscous force acting on the ball is. So over here we can just consider that when an object is inside a liquid, the forces acting on the objects are, one is nothing but weight of this object mg, another one is the upthrust acting on the object, and the equation for upthrust is volume of object into density of liquid into acceleration due to gravity v rho g. Other than that, a viscous force of F is acting. Now in situation it is given that particle is moving with a constant velocity. If the particle is moving with a constant velocity, net acceleration is equal to 0. That means the value of net force acting in upward direction, that is Fv plus V naught into density of liquid into G, should be equal to mass of object mg. So in question they are asking to find out then the viscous force acting on this one, Fv is equal to nothing but mg minus volume of object into density of liquid into G. So we can write this is equal to m into g minus volume of object into this density of liquid. In this question it is given that the density of glycerin is d by 2, that is density of object divided by 2 into g, and we know that the volume into density is nothing but mass of object, so we can write this is basically mg minus mg divided by 2, which is equal to mg by 2. That is the value of viscous force acting on the liquid, or the viscous force exerted by the liquid on the object.